Atacama Oases. It's not about what you see, it's about what you hear, so you can truly understand. Subscribe now, because the videos coming next are going to be bigger, better, and way more exciting.
Could life actually be hiding under a thick, icy shell on those distant moons? And what kind of evidence has got scientists convinced there are liquid oceans in places where sunlight barely ever touches? How on earth does water stay liquid when the temperatures are hundreds of degrees below zero? Why have these two icy moons become the absolute obsession of global space agencies? And what space missions are actually trying to unlock their secrets in the coming years? Humans have been obsessed with finding out if we're alone in the universe for, forever. For the longest time, all the hype was focused on Mars since it's our closest neighbor and the most Earth-like place around. But in the last couple of decades, researchers have shifted their focus to two totally unexpected icy worlds. Both Europa, one of Jupiter's moons, and Enceladus, which orbits Saturn, have some wild stories to tell based on what the science is finally showing us. When it comes to Europa, the geological data is wild. It's got this super thick icy shell covering its entire surface. NASA estimates that this crust is only about 15 to 25 kilometers thick. But here's the kicker. Beneath that ice sits a massive global ocean that could be anywhere from 60 to 150 kilometers deep. That means there's actually way more water on this moon than in all of Earth's oceans combined. Enceladus is way smaller than Europa, though. Its diameter isn't even 500 kilometers. But even with its tiny size, it's low-key one of the most fascinating spots in the entire solar system. Back in 2005, NASA's Cassini spacecraft spotted these insane water jets blasting off from its south pole at speeds hitting 400 meters per second, shooting up 200 kilometers above the surface. The scientific instruments on board Cassini analyzed those plumes as they flew right through them, and man, they found the most mind-blowing evidence yet. Those jets were packed with water vapor and gases like methane and ammonia, plus solid grains of silica. The analysis also picked up complex organic compounds and salts that are straight up identical to the stuff we find in our own seawater here on Earth. Finding these organic compounds doesn't automatically mean there's life out there, but they're basically the essential building blocks for life as we know it. Computer models are suggesting that the seafloor on Enceladus might actually have hydrothermal vents just like the ones we have at the bottom of our own oceans, where life totally thrives in total darkness without ever needing a single ray of sunlight. So the question everyone's asking is, how on earth can water stay liquid hundreds of millions of kilometers away from the sun? The surface temperatures on these moons drop to like 160 degrees Celsius below zero, which is way past the freezing point, right? This massive contradiction basically forced scientists to hunt for another heat source, and they finally found it in a phenomenon called tidal heating. So, the insane gravity of the parent planet literally stretches and squeezes the moon as it orbits, which is wild. The moon is constantly getting pulled and compressed over and over again. For example, Jupiter causes Europa to deform by as much as 30 meters during every single orbit. All that constant stretching creates massive internal friction, and that energy turns into heat, keeping the water liquid beneath the icy crust. That thermal friction is basically a built-in heater that's been running non-stop for millions of years. Scientists estimate that the heat generated inside Europa hits about 0.3 watts per square meter of its surface. That might sound like a tiny number, but it's totally enough to keep that entire ocean liquid and stop it from freezing solid. It's exactly the same vibe as those subglacial lakes trapped under the ice at Earth's poles. On the other hand, the heating mechanism on Enceladus is a bit different because of how tiny it is. Since its orbit around Saturn isn't a perfect circle, it's more like an oval, the gravitational pull it feels is constantly changing throughout its orbit. That tug-of-war creates way more friction and generates a much higher amount of heat for its small size, which is exactly why we see those super-active water jets blasting out of its south pole. That internal heat is also a total game-changer for shaping the icy landscapes on both of these moons. Over on Europa, spacecraft have actually spotted terrain that looks a lot like tectonic plates, where huge chunks of ice collide and get shoved on top of each other. It's wild. There are these spots where the ice cuts across itself, just like the fault lines we have in Earth's crust, which is a dead giveaway that there's some serious ongoing geological activity constantly reshaping the surface. Studies haven't just relied on visual stuff, though. Scientists have been using some seriously clever remote sensing tech to dig deeper. These tiny, subtle shifts in Europa's orbit around Jupiter revealed so much about what's going on inside. By using radar and precision imaging to measure how the moon's gravity changes as it orbits, they were able to figure out that there's a massive body of water sloshing around under the surface, constantly reacting to Jupiter's gravity. On the flip side, space agencies totally get how huge these discoveries are, so they've greenlit some seriously ambitious missions to go explore these icy worlds. NASA's Europa Clipper mission is locked in to reach orbit around Europa in 2030, and it's going to make over 40 super-close flybys, getting as low as 25 kilometers from the surface. The craft is packing 9 high-tech scientific instruments to study that ice and the ocean underneath. Meanwhile, the European Space Agency is planning another massive mission called JUICE, which is also set to hit the Jovian system. This mission is going to be laser-focused on studying Europa, Callisto, and Ganymede to dig into the possibility of hidden oceans beneath their surfaces. Plus, there are some really exciting proposals for future missions that could actually land on the surface of Enceladus, and if these missions actually manage to find even a shred of evidence for microbial life under the ice, it would totally change our entire understanding of the universe forever. If life exists in 2 different spots right here in our own solar system, it could mean that life is actually super common throughout the cosmos and not just some rare fluke. That would honestly redefine Earth's place in this massive, endless universe and open up some wild new frontiers for scientific research in the coming decades.